next series we're going to see from Conbraco is the 4A series of backflow prevention assemblies. Conbraco has had a name adjustment, if you will. You may see the name Conbraco, which is the parent company's name, or you may see the name Apollo as a model number on the backflow assemblies. They're using the designation of Apollo as a model number, as a model description for the backflow prevention assemblies. So Conbraco, which was kind of a brass company, which is the parent company, Apollo, which is a model under the Conbraco name. So if you see both names, don't let it confuse you. The 4A series is their latest generation of assemblies. Like the previous generations, they utilize a two-digit 4A. We saw the 4A series, we saw the 4D series, the 4S. Now we're seeing the 4A series, the 100 being double checks, the 4A-200 series being their reduced pressure assemblies, 4A-500 PVB, same as the other model designations. The 4A series also has a designation where it utilizes the type of assembly, DC, with the 4A configuration. So you may see 4A-100, or you may see the DC 4A series. They're also producing it in a lead-free version in the small 2-inch and under assemblies. So you may see the 4100 series, the DC 4A, or DC 4A LF, as you see here. But they're all within the 4A-100 series of assemblies. They're going to be available in sizes 1/2 inch through 12 inch. The 1/2 through 2 will be the small, and they will be available in either a leaded bronze or a lead-free bronze body. The 2.5 through 8 inch will be available in a stainless steel fabricated body, and the 10 and 12 inch will be available in a ductile iron body. On the small sizes 1/2 through 2, as I said, they're available in both lead-free and standard leaded bronze. They utilize a top entry configuration, test cocks pointing up on the top. Screw covers open up the check assemblies and access a modularized check on the inside. As you can see the breakdown here, here's what the modular check looks like. Here's the check in an exploded view. There's a spring retainer, a spring, a disc holder, the disc retainer screw, and the check seat. And the check seat is sealed into the body with an O-ring. It goes into the body like this. On the larger sizes, 2.5 through 8, will be a stainless steel body fabricated, meaning that they weld pieces together to assemble the body. The 10 and 12 inch will be a ductile iron body. There's a standard poured material with a fused epoxy coating. The check modules will be modular in this design. The check modules look similar to what we've seen in the 4D series. They are a tri-spring mechanism with a center guided check. Again, they're modular, so the check comes out in its complete working parts. And here's an exploded view of what the module looks like. The end configurations will have a grooved end, so the gate valves will be a flanged by groove end. They'll also be available in grooved by grooved end if you so desire. But the body itself only comes in a grooved configuration. They're also making an end pattern configuration, end meaning end shape, where the inlet comes up from the bottom, goes out horizontally and back down in a vertical configuration. This is available for areas where you need a small footprint of the installation. You want to install the assembly in a relatively small area. Again, 2.5 through 8 will be available in stainless steel. The 10 and 12 will be available in an epoxy coated ductile iron. They will utilize the same check mechanisms as used in the horizontal pattern. They also have available what are called valve setters. And valve setters for the end pattern configuration make it for an easy installation orientation, so that when you go to install this in the underground area, you can have L's that have a preset distance between them, so that the center to center matches up with the center of the backflow assembly. So all you do is cut your risers for the up and down between the adapters, and then lay your piping in the ground for an underground installation. The series comes, as I say, 2.5 through 12, and let's see what they look like inside. The 4A series of double check, meaning the 4A-100 or DC 4A, as you may see both versions of it. This is the small, meaning 2-inch and under assemblies that they're producing. And they are available in either a leaded bronze assembly or lead-free bronze assembly for the main valve and the bypass and test cock units. Check covers thread on from the top. There is a hex head on the top of the cover for removing of the cover. The spring is contained when you remove the cover. There is a cover O-ring here. And once you take the cover off, what you will see is a spring retainer, which looks just like this. Here's a larger version of it, what you're looking at inside that check assembly. For the average repair, you can push in on the spring retainer, rotate it 90 degrees. The spring retainer will come out, check spring, disc holder. The check seat, which is just pressed into the body at this point, can stay in the body for the average repair. The reason is this O-ring that sits inside the body here is sealing that sealing that seat inside the check body. And anytime you do not have to release a spring load on an O-ring, it's not a bad idea. But you can repair it this way, or you can remove the entire check assembly, which is what this looks like, except this being a 2-inch version. Same story, that 90-degree rotation releases the spring tension, which allows the disc holder to come out. And here's where you can see the check seat cast into the plastic. There is an O-ring, as you see right here, that seals that O-ring to the body, so it's just pressed into the body and held in by the cover as it pushes on top. So you can either do it this way where the spring stays in there, remove the check module. Rebuilding it is a matter of one screw holding the silicone disc into the disc holder, replacing the disc. It's a symmetrical flat disc. Putting it back together is going to be just the reverse. Larger check assembly outside the body so you can kind of see it a little easier. It looks like this. Now, there's one little thing you want to be aware of when you go to put this back together. This spring retainer, I'll take the spring out for a minute, pushes down here and rotates 90 degrees inside the body like this. Now, it's possible to have it rotate and not completely inside the body, because once it rotates 90 degrees, it actually lifts up a very small amount, as you can see right there. So to make sure it's all the way in, it has to rotate in and push up. Remember, the spring force is pushing up on it, so when it does go down, it will have a definite force, and you'll actually hear a clicking sound like that. See, that's where it's improperly applied. See where the spring retainer is slightly down, but rotating at full 90 degrees, it'll pop up just that little 1/8 of an inch, and you'll hear that clicking sound. Very, very important that that be in this position, because if it's like this, you're going to have some issues with the flow characteristics of the body. So the spring retainer must be in its full opening condition like that, so that it's all the way up. Listening for the clicking sound is a good idea. Like all O-rings have to be properly lubricated. Yes, Conbraco provides a little pillow of grease for this. Proper application of grease is you put it on your fingers, you wipe it all the way around the O-ring, and then place it on the check module. Don't put the O-ring on there and then wipe the grease on here, because that won't lubricate the O-ring properly. Proper lubrication of O-ring, as we've said many times, is in your fingers, rotate all the way around 360 degrees so that it's lubricated properly all the way around. If you did not remove the check assembly from the body, reassembling is going to look like this. Same story, we have to be very careful to make sure we have our spring retainer and want to hear that clicking sound that it pops into that area. The cover is also sealed by an O-ring, so we want to make sure the O-ring cover is properly lubricated also. Reassemble and tighten the covers back on. Those are the check modules of the 4A-100 series 1/2 through 2 inch. The 4A series in the double check, meaning 4A-100, in the large sizes 2.5 through 12. The 2.5 through 6 is going to be a stainless steel body, or 2.5 through 8 is going to be a stainless steel body like we see here, but it's a fabricated body. Fabricated meaning we have pieces of stainless steel that they extrude into the shape and weld the pieces together to fabricate or construct the body. So by having a few pieces that are welded together, by the nature of welding, there's slight dimension changes that could happen along the weld. You could have approximately a 1/16 to an 1/8 of an inch difference on a weld. So the end-to-end dimension, depending how many welds are on the body, depending on your size, could be off by that small dimension. So if you ever have to replace the body or you're putting it into an existing body, it's very important to check that end-to-end dimension, because they could be different because of the body. On the 10 and 12 inch, it is a poured ductile iron material that's used epoxy coated. And since it's a poured body, you'll have a standard dimension on the 10 and 12. They're utilizing something new. This clamp that you see on the top, a quick connect clamp to have access to the check modules underneath. So by utilizing a small 1/2 inch deep socket, it allows you to come in here and loosen this clamp. Once the clamp is loosened, you can compress it inward, sliding outward like this, and the clamp will come off in one piece. In other words, this little hinge comes over here, so that holds on to there, and that's how that clamp operates from the top. It's sealed by an O-ring on the top. cover comes off next, and underneath the cover you'll see there's the O-ring slot, and this is where the O-ring seals on that body right there. The test cock on this is our number 3 test cock. Test cock 1 and 2 are going to be mounted on the inlet gate valve. Test cock 3 will be on the cover, and test cock 4 will be here. Test cock 4 you can see is just a standard male thread going into the body, but test cock 2 has a bulkhead fitting that we've seen on some of the other versions inside the cover. So it's not just a standard test cock from that standpoint, but it operates on a bulkhead type configuration. To remove the checks, we're going to have to remove this clamp right here. And you can see the 2 little fingers protruding through the top. By entering and squeezing those, the clamp comes out from the top like this. Next will come out a spacer, which is in there to add additional strength, and that's what holds the check assembly with a small handle on the back side, allowing the check assembly to come out in one piece like this. So what you're seeing inside the body is this guide here, the spacer for strength, and the clamp that hooks into the body like that. So that's the check mechanism. Clamp, spacer, and check assembly. So here's what the check assembly, the check module looks like outside the body. As we saw in the body, it looked like this, as I said. The little handle on the back is to grip it to get it out of the body. It's sealed by an O-ring, and here's where the O-ring sits inside that check module. That's what actually seals that check into the body. Once we have the check assembly out, you'll notice here's that tri-force spring, the 3 different springs that you'll see on the check mechanism. The springs are not field replaceable, and the factory won't even sell them to you because they don't want you taking the springs apart for the average repair. For the average repair, those don't have to be touched. For the average repair, all you're going to do is on the back side, there'll be 4 little nuts. 2 of them will be holding this little handle. As you can see, I'm missing 2 of the nuts. Retainer washer, and then a disc holder. Disc holder comes off, silicone rubber disc. Comes out, it's a symmetrical round disc. The check seat is right here, and you do not have to disassemble the check module any farther than that for the average repair. So for the average repair, all you're going to do is replace the disc, just the reverse of what we saw. Get the check assembly back together. Retainer plate, 4 bolts, 2 of them holding down the handle. We want to take the time to tighten the 4 bolts evenly. Want to properly lubricate our O-ring, again greasing your fingers, rotating the grease all the way around 360 degrees, inserting the grease around the check assembly, ready for reassembly. Before we put the checks back into the body, you do want to inspect the body, make sure there's no signs of debris or anything inside the body. Since it's a stainless steel body, we should not have any other issues other than making sure there's no dirt inside there. Reassembling of the first check and second check, this being the first check. And obviously I didn't take the second check out, but to get the second check out, the first check has to come out first, and vice versa. So what we're going to do is install it this way. First check going into the body. Now we are compressing this, squeezing this O-ring through this retainer right there. So it's important that we get that check assembly all the way back in. This spacer is there for added strength that holds it into the body. Yes, I'm going from the side, but you can see right here where it holds that into the body, and we still see the small little recess here where that clamp is going to go right there. So the clamp is a spring clip that you see like this. So we're going to insert it in from the top, squeeze the clamp from the center, and this clamp will sit right into the slot right here and right here, as you can see from the bottom. So the check assembly is firmly held in by the clamp with the support bracket. Here's the O-ring that seals the check into the body. See the second check in like that. Now you can see the check assemblies are in. You can see our second check and first check. You can see a close-up now of what that spacer and that ring looks like that holds that check into the body that we just took out. The bolts tightened on the back side. I'm actually missing 2 of them here because it's a demo. I want you to see the clip from the top. Now you can see what it looks like up there, those 2 ears. And that's what you need to see on that clip that's sprung in there, and that check needs to be in tight. Once we've got the second check and first check in, now we have to take a look at the cover. This is what the cover looks like. One thing I forgot to mention is that the cover actually has 2 screwdriver slots on it. You can see right here. So that when the cover is on, you are able to get a screwdriver to remove the cover easily when you're taking it apart. So those two slots that are sitting, one right here and one on the opposite side, can be seen from the side for when you take it apart. Putting it back on, the cover is sealed by an O-ring. The O-ring, like all O-rings, has to be properly lubricated. Lubricate your hands, pull it 360 degrees around, then put the O-ring on the cover. Don't put the O-ring on first and then try to lubricate it. Second issue about the cover to notice is that the test cock is actually mounted by a bulkhead fitting. You'll notice test cock number 4 is a standard threaded test cock, but this one is, because of the cover, has a bulkhead fitting attachment that holds it to there. So once we have the O-ring lubricated, O-ring on, now it's time to place the cover on. Get the cover centered, go ahead and push down. Now for the quick connect clamp. You saw as we took this apart, now we have to put it back together. So the quick connect clamp goes around there. You'll notice on the body that there is a V shape. In other words, the body rolls out this way and the cover rolls down that way, and there's a corresponding valley inside the clamp right here. So it's designed to go inside that little valley, and the cover goes over the top just like this. Now tightening this cover. It's very important that we have it properly tightened. 1/2 inch deep socket is needed. If you have a speed wrench instead of a ratchet, that goes a lot faster. But I do want to show how it's to be tightened, because I want to get it so that it's snug. See, it's still loose here. I want to get it so that it's snug first, because what seals this cover is not the tightness on this clamp, but the O-ring. So once I have that cover snug like this, now it just takes a couple of points beyond that. In other words, this cover is not sealed by the tightness of the torque of this bolt, but by the O-ring. The V shape of that clamp holds that body and cover down and holds that in place. So this has to be properly tightened, but not over tightened. Over tightening can actually torque the body and cause some issues with it. So this is what the 2.5 through 8 inch is going to look like with the stainless steel fabricated body. The 10 through 12 inch is going to be a ductile iron body. Instead of fabricated steel, it's going to be a standard cast, in other words, molten metal pulled into a mold. So it'll have the same end-to-end dimensions, unlike the fabricated body. It's going to have the groove coupling cover on the top instead of the quick connect coupling like this. The checks, instead of having the spacer and the clamp ring holding it in place, the checks are actually bolted into the body because it's so much larger. But it does have the same disc design where you take the disc nuts off the back side to replace the check disc. So it's similar check mechanisms. The main difference is the checks, because of their size, are bolted in rather than held into a clamp. So this is our double check series, the 4A-100. 2.5 through 8 inch are going to be stainless steel like this, fabricated. The 10 through 12 are going to be a cast ductile iron body. The checks are modular on both of them. 2.5 through 8 held in by clamps. 8 through 12 bolted into the body. The 4A-200 series is going to be the reduced pressure principle backflow prevention assemblies from Conbraco. Conbraco is the parent company. They're also using the name Apollo as a brand model of this particular type of backflow prevention assembly. So you might see Conbraco, which is the parent company. You might see Apollo on the valve, or both. And the 4A-200 series, which is the series of the assembly, may also be designated as the RP4A, and the LF in the small versions for lead-free. This comes available in sizes 1/2 inch through 12 inch. The 1/2 inch through 2 are going to be a bronze or a lead-free bronze body. The 2.5 through 8 inch are going to be a fabricated stainless steel body, and the 10 and 12 inch are going to be a ductile iron body that is fused epoxy coated. The 1/2 through 2, as I said, is available in either a standard leaded bronze or a lead-free bronze. 2 access covers for each check from the top, screw in from the top, hex head cover, relief valve cover on the bottom, the relief valve below here, inlet outlet shutoffs as we see here. They use a modularized check assembly for the checks, as we saw in the 4A-100 double check series. Here's what the check module looks like outside the body, with a spring retainer, our spring, our disc holder, our check disc retainer washer, disc washer bolt, and our check seat and seat O-ring. This check module mounts inside the body. It's pushed in there. It is not held in by any type of a fastener, and cover holds it on from the top. On the bottom where the relief valve is, we have a relief valve cover down that comes off, Once the cover comes off, we have our relief valve diaphragm, which is loose. Our relief valve stem assembly is underneath that diaphragm, which comes out in one piece. Disassembling one screw on the back side here allows you to remove the relief valve disc. Reducing the screw on this side releases the relief valve spring tension from the spring retainer washer, and our guide and our stem, which has an O-ring mounted in the center, and our relief valve seat, our disc. The relief valve seat pushes into the body and is sealed by an O-ring inside the body itself. The large size is 2.5 through 12. We're going to see two different body materials. In the 2.5 through 8 inch, we're going to see a stainless steel body with a fabricated steel construction, meaning that pieces of the tubing are welded together to fabricate a body. The 10 through 12 inch body is going to be a ductile iron body that's fused epoxy coated. The relief valve is mounted underneath the body, relief valve sensing line coming off the inlet shut-off over here onto the relief valve cover in the center like this. The relief valve assembly is mounted underneath. It does not have to be removed from the body for the average repair. It just has to have the cover and the hose removed for the average repair. The breakdown, what you'll see, is a modularized check assembly. The 2.5 through 6 inch will have checks held in by small retainer clips, spring clips, as we saw in the 4A-100 series. On the larger sizes, which we see down here, the check assemblies are actually bolted into the body. And the bolt configuration like this, instead of a clamp, or a clip, is what holds it into the body. There are 3 different sizes of relief valves. There's one that fits 2.5 through 6, one for the 8, and a third one that fits 10 through 12. The 2.5 through 6 up here has a cover comes off, separate O-ring, relief valve stem, which can be exploded out here, relief valve seat, which presses into the body, similar as we saw in the 2-inch design. They also produce an N configuration for the reduced pressure assembly in the 4A-200 series, and also a configuration where the water pressure will come from the bottom, go horizontal, and go in a vertical orientation. So whether it's up and down or up and over like this, because of the body having a groove coupling in the middle, the second check can be rotated to give you different orientations of either up and down or up in like this configuration that you see here. They also produce a reduced pressure detector assembly version of the 4A-200 called the 4A-700 series, or it may be the RPDA4A series, also an N pattern configuration as we see from the model number. The horizontal version, the RPDA4A series, 40-600 or 800, 700 series, excuse me, has a horizontal piping configuration. The check bodies are grooved in, so the gate valves will be grooved by flange, as we saw in the double check version. And they also have a Type 1 and a Type 2 bypass assembly available. As we discussed in the 4A-100 series, the Type 1 bypass has a backflow assembly of equal protection, where the RP main line has a bypass RP. Type 2 is where the bypass has only a check valve that goes around the second check. So Type 1 or Type 2 bypasses are available. It is also available in an N configuration with the double RP detector assembly, both Type 1 and Type 2. Let's take a look and see what they look like inside. The 4A-200 series, or RP4A series, there's a small 3/4 inch what it would look like, comes in either a leaded or a lead-free bronze assembly. And again, repair parts will be the same for either version. Showing you a cutaway version of it here on the inside. You'll see what the checks look like in the middle, relief valve underneath. Modular checks, meaning that when I have hex cover on top, go ahead and remove my cover. Cover comes off, and what I will be exposed to is a check module. What you're actually looking at right here is a spring retainer. For the average repair, you don't have to remove that check module. This is what a 2-inch check module looks like, sitting in there like this. But you are able to just take the spring retainer, rotate it 90 degrees, release the spring retention, spring retainer, spring, and disc holder comes out in one piece like this. One screw holds the disc into the disc holster. This utilizes a silicone rubber, as you see there. What the check mechanism looks like in a large version, so you can see it apart, because you can remove the check assembly. The check assembly is sealed into the body by an O-ring. This O-ring right here is where it seals in the body. So for the average repair, by just taking this apart, you don't upset the load on this O-ring. But if you have to remove the seat for some reason, then that O-ring can be easily replaced. Spring retention, as you can see, a little easier with the larger one. Spring retainer, spring, disc holder, and seat. So that's the check mechanisms. If you're rebuilding the check outside the body, going to be just the reverse. replacing one screw to replace the check disc in the disc holder. Now the problem with the check is that you have this retainer. If you'll notice, the retainer has these little clips on the side, which are meant to go down through this recess and rotate 90 degrees. But you'll notice once it rotates 90 degrees, it can move almost a good 1/8 to 1/4 of an inch on that 2-inch assembly. So you want to make sure that that's in the right spot. What you will do is, once you have the spring loaded, and make sure the spring is centered around the disc holder. It is possible to put the disc holder off to one side like this, and if you do that, it causes a hipping action like that, which causes a lot of issues with spring load. So make sure that your spring is symmetrical in the center of the disc holder. Spring retainer from the top. Pushing down, you want to rotate that spring retainer 90 degrees, but you want to listen for a clicking sound. Listen to this. That click tells you, and you saw how it popped up there at the end, shows you that it's in the right spot. Right there is incorrect. That is correct. It will actually raise up almost a 1/4 of an inch above there on the 2-inch size like that. If you're rebuilding the checks and not removing the seat from the body, you can replace the disc hold into the disc, like into the disc holder. Spring goes in next. Your spring retainer goes in here. You want to do that 90-degree rotation. You want to hear that clicking sound. Same thing. You want to make sure it gives that click, just like that. Cover O-ring. Make sure the O-ring is properly lubricated on the seat if it's replaced, and the cover. Remember, proper lubrication, as we've said many times, as the O-ring comes off. Grease in your fingers. Push the grease all the way around 360 degrees. Then place the O-ring on the cover. Cover goes over the assemblies like that. Over the body, like that. And that's our check mechanisms in the 4200 series. Let's talk about the relief valve now. Here's what it looks like without the cutaway side, and here is a cutaway side, so you can see what looks inside there. You'll notice there's a relief valve cover, our diaphragm, our relief valve stem, our relief valve seat on the back. So we're going to remove our cover bolts off of this. Once we remove our cover bolts off, what we're going to see is a diaphragm. This is a 2-inch diaphragm. This is a 3/4 assembly. But once you take the cover off, it exposes the diaphragm. The diaphragm comes off loose, and what you'll next see is this stem assembly right here. By grabbing the spring retainer, it'll come out in one piece just like that. The relief valve seat pushes into the body. It is not held by any kind of fastener. There's an O-ring seal right here, so it's a friction fit that sits into the body, and the relief valve stem goes on top of it like this, and your diaphragm sits on top like that. So that's what you're looking at inside that body, is the diaphragm, stem assembly, and seat, just like that. The 2-inch is a little bigger to see than it is on the small 3/4. So let's go ahead and take that stem apart so we can see what it looks like. Again, the seat stays inside the body for the average repair. It is held in, sealed by an O-ring. Stem moves back and forth like this, as you can see. The movement of the diaphragm compresses there. So what we're going to need is a screwdriver. One screw removes the relief valve disc and disc retainer washer. Turning it over allows me to remove the spring tension from the stem. Phillips head screw comes off next. There will be spring tension from the relief valve underneath. And relief valve spring retainer, spring, our relief valve stem. This is our relief valve guide, and very important O-ring that you see right here in the center of that stem. That O-ring is one of the critical parts of that relief valve. And as you can see, it sits in the middle of that guide. So as this O-ring, as this stem travels back and forth, this O-ring sits in the center, and it has to seal as it moves back and forth. It's called a dynamic O-ring, an O-ring that must seal with movement. Very, very critical that this type of an O-ring be properly lubricated. Again, proper lubrication is wiping all the way around 360-degree fashion, putting the new O-ring on. That. Want to work it through the guide to make sure it moves easily. That should move literally just that easy back and forth. If you have any kind of problem with that O-ring moving back and forth, the rubbers that we're utilizing on this design are resistant to chloramine attacks. So fortunately, we should not have any interface where this O-ring swells like we have on some of the other black rubbers that are out in the market. So you can tell that if that O-ring was swollen for any reason, that it would resist movement across that guide. And if it resisted movement, that would affect our relief valve opening point. Reassembly is going to be the reverse. I'm going to go ahead and once we have our spring retention on the cover, relief valve disc goes on the other side, relief valve disc retainer, our relief valve disc retaining screw. Now, back to what we would be seeing here, and I'm showing you on the 2-inch size because it's larger, a little easier to see. When we're reassembling this, that relief valve seat sits in the body like this, and we're going to be installing this looking from this direction, trying to hit that seat in the center. So it's kind of a blind assembly. So we want to make sure we hit it straight center because we want to make sure that stem moves easily through there. So as you go to put the stem back in, gently push it until you get into the slot, and you can see how it sits like that. And then once it's in the body, now we have our relief valve diaphragm. Make sure we line up our high pressure sensing line, which is attached up here in the body, right over here, with that extra hole that we see in the diaphragm, lining it up. Relief valve cover, and that's our 4A series in the small sizes, meaning 1/2 through 2-inch. In our 4A series in the large, meaning 2.5 through 12, the 2.5 through 8-inch are going to be a fabricated stainless steel body. The one-piece horizontal body over here you see where it's a fabricated body where pieces are welded together. They also have the end pattern configuration for the up and down configuration, with a groove coupling in the middle so that we can rotate that second check 90 degrees, 180 degrees, whatever we had to rotate it to get our check in an up and down our flow in an up and down configuration. We're utilizing a quick connect clamps again on both checks on the end pattern and on the relief valve. Single access cover on the horizontal pattern as you see here. I'm going to take the end pattern apart first so we can see the relief valve, and then we're going to talk about the horizontal pattern because the mounting of the check mechanisms is different. You'll notice in the end pattern there's this little retainer in here that I can move easily on the side holding our checks, versus the horizontal version. What we see is the clip with the spacer washer that we saw in the 4A series. So let's go ahead and take the end pattern apart. Start by removing the clamp. Again, 1/2-inch deep socket is needed to remove our clamp, which allows you to loosen that up. Once you have it loose, squeezing of the clamp will allow the clamp to come off in one piece. So the clamp has a little T-bar on the back that slides over here, and that's what it sits like inside the body. Once I have the clamp off, there are 2 screwdriver slots that allow a screwdriver to come in so you can move it up and easily remove the cover, which is sealed by an O-ring that you see right here. On the cover, you'll notice that the test cock is a bulkhead fitting mount. If you look from the top where the stainless is, look on the bottom, you see the lock nut, as opposed to the standard threaded type test cock that you see over here on number 4. Once we have the cover off, what we're exposed to is this plastic piece I was showing is a spacer. And the spacer comes out in one piece. So the spacer sits there with the cover pushing down on it, and that's what holds the check mechanism into the body. The check is sealed by an O-ring, has a handle on the back side so it can come out from the top. Here's where you can see that O-ring. Check assembly comes out in one piece. Tri-force spring like the 3 loads that we saw on the 4A series. Check assembly sealed by an O-ring into the body. To rebuild the check assembly on the back side, we're going to see 4 small little nuts. Removing those nuts come off, removes the handle. The handle is held underneath those nuts like this. Our washer and our disc holder come off in one piece. Silicone rubber disc is utilized on the check mechanism. Comes out as a flat symmetrical disc. Replacing the rubber disc is this. The check mechanism does not have to be adjusted or changed in any way. Springs are not field replaceable. If you need anything more than just the basic rubber parts for this, you will have to buy the entire check module. Reassembling is going to be just the reverse. New rubber disc, disc holder, our retainer plate, our little handle. We're going to go ahead and put our nuts on the back side of that check assembly. I want to make sure we tighten it evenly as we tighten it down, so we don't put any undue forces on the back side of that plastic, causing any kind of tension. Replace the O-ring, proper lubrication of the O-ring, as we've said many times. The O-ring has to be greased 360 degrees all the way around. Assembling from the top, check assembly goes in. Here's where you can see that O-ring seal. So as I push down, you can see from the side where that O-ring seals, right inside that body, right there. Now, once I have that check mechanism in, the spacer goes in from the top, which allows me to take my cover, pushing on the top here, making sure I've got it all the way down across here so that I know I've got force on that spacer. You see here, now you can see how it's actually very hard to move when the cover is not on. The clamp, again, comes off like this. The T-bar allows it to catch in that hook that you see right here. And the clamp will connect just like that. Get a 1/2 inch deep socket. Allows us to come in here and tighten that up. The second check has a small little variation on this because we're at that angle. When we go to remove the clamp and we go to remove the cover, you can see how it's very easy, gravity making everything just kind of fall out. Check assembly is held in the same way with the O-ring. But the problem is getting this spacer back in, which you see falls, and then I'm going to try to get the cover at that angle. Easiest way to do that is to go ahead and put the retainer into the cover. You notice the slot that sits in like that. And by holding it in the slot like that, does make it a little easier to get into the body, making sure I've got it in straight. And now you can see from the side how that works. Same type of quick connect clamp that we saw on the first check. On the second check, reestablishing the clamp and tightening it up accordingly. Now the horizontal body has a little bit of different check installation that we want to talk about. This is a double check body, but the relief valve mounts from the bottom here. But I'll just show you the double check body to show you how the check mounts in the horizontal versus the end pattern comes apart. Same clamp, except we have one clamp only on the horizontal design, and same quick connect clamp. Same cover where we've got our little screwdriver slots on both sides so that we can come in here and remove the cover. Cover is attached by, or sealed by an O-ring seal, we see there. Same type of check mechanism we just saw over here, but what's different here is this little spring clip that you'll see right here. And I just push it to the side so you can see. From the top, it squeezes in like this, so you have to actually squeeze it and then pull it out like this. So it'll be mounted up on the top portion, taking the two little clamps, squeezing it allows you to pull the clamp out in one piece from the top. Once I have the clamp off, you'll see this little stainless piece here. It's a spacer that comes out, and it's there for added strength of the check assembly, the body. And then the check has that same handle that we saw, which allows you to pull the first check out and pull the check out from the top. The check comes out in one piece like that. Same bolts on the back side for changing the disc. The difference is the mounting mechanism. And that's where we have this spacer plate and this retainer clamp. And here's what it looks like outside the body. So by squeezing it like this, getting it on, releasing it, and that's what it will sit like inside the body. So same repair procedure, remove the 4 bolts, allows you to change the disc holder. We've already done that. Let's go ahead and mount the horizontal check back into the body. So we're going from the top, mounting our check assembly in like this, using our handle to rotate the check. Now here's where it's very important that this O-ring gets pushed all the way back into that body. In other words, when this check assembly gets into the position, we want to make sure that O-ring pushes all the way back so that we have a nice spot here and a nice spot for the retainer. Because remember, this spacer has to sit right there, and then after it we have to have this. So we want to make sure we've got all our space in here so that the check assembly is fully pushed back into the body. Next, our little spacer, which is there for strength. And now for the spring clip. This is what it looks like unsprung, but that's what I'm going to do, is squeeze it like this, push it into the body, get it into the clip. So by pushing it in from the top, getting it around on the bottom, like that, around the sides, and the spring clip will go in just like that. So seeing the clip from the top, you can see the 2 points here where we spring to hold that together, seeing how it sits inside the body here. Next, our cover goes back on. Proper lubrication of the O-ring. O-ring has to be lubricated off. Take it off through your fingers, just like we've said a bunch of times. Now for the quick connect clamp. You saw as we took this apart, now we have to put it back together. So the quick connect clamp goes around there. You'll notice on the body that there is a V shape. In other words, the body rolls out this way and the cover rolls down that way, and there's a corresponding valley inside the clamp right here. So it's designed to go inside that little valley, and the cover goes over the top just like this. Now tightening this cover. It's very important that we have it properly tightened. 1/2 inch deep socket is needed. If you have a speed wrench instead of a ratchet, that goes a lot faster. But I do want to show how it's to be tightened, because I want to get it so that it's snug. See, it's still loose here. I want to get it so that it's snug first, because what seals this cover is not the tightness on this clamp, but the O-ring. So once I have that cover snug like this, now it just takes a couple of points beyond that. In other words, this cover is not sealed by the tightness of the torque of this bolt, but by the O-ring. The V shape of that clamp holds that body and cover down and holds that in place. So this has to be properly tightened, but not over-tightened. Over-tightening can actually torque the body and cause some issues with it. So this is our horizontal-oriented body. Again, this is a double check body. As an RP, the relief valve will be mounted under here, but you see the idea. So the checks that we've seen this and cover on. Now we want to take a look at the end pattern, which has a little bit different configuration. And again, same thing. That clamp that we concerned ourselves with the cover, same story happens on this one. So there are 3 clamps, the one on the first check, the relief valve, and of course the second check. The tightness of this clamp is important, making sure we have it tight enough, but we don't over tighten it so we don't torque anything. The differences on the end pattern is that the check assemblies are not held in by that retainer ring, but they're held in by that plastic spacer that holds them in place. The 10 through 12 inch body in the end pattern also will be ductile iron fused epoxy coated. Similar construction as we see here. We're not going to have we'll have the spacer mechanism that holds those together. Difference being that the body itself is going to be ductile iron and fused epoxy coated. The groove coupling in the middle allows for the orientation to change the second check in a straight up pattern so we can have vertical orientation. So that's the horizontal checks. Let's go ahead and take a look at the relief valve now. The relief valve is mounted underneath the check body. This is our end pattern configuration. The relief valve mounting on the horizontal configuration would be mounted here, this being a double check body, but you can see the flange there where that relief valve would mount underneath. So whether it's a horizontal body like this or the end-shaped body like this, that's our relief valve that will mount underneath. The sensing line, which is not shown here, this is a 1/2 inch thread right here. The hose comes from the number 1 shutoff and attaches to our cover right here. Obviously it's a cutaway, so we don't see the relief valve sensing line, which would attach right here. So first I have to remove my high pressure sensing line. We have another of our quick connect clamps, so we have to get our 1/2 inch deep socket in here again, loosen that up. Allows us to remove the clamp like that, just like we've seen on the check mechanism several times now. The relief valve cover is going to come off in one piece like this. This is obviously a cutaway, so you can see the hole in the center there. Once we have the cover off, what we're going to see is our diaphragm. And our diaphragm is connected to our relief valve stem. So by grabbing our diaphragm, what we're going to do is pull the stem out in one piece like this. The relief valve seat sits inside the body. It's not held in by any fasteners, but it's sealed by an O-ring on the back side like this, and does not have to be removed for the average repair unless the relief valve seat is damaged in one way or another. Repair of the relief valve stem. We have a bolt on this side which holds our relief valve disc into the disc holder. Disc retainer washer disc allows us to turn it over. Now on the back side we have a bolt that holds our relief valve spring tension. So we have to be careful as we go to remove this bolt. There will be spring tension underneath from the cover, on the diaphragm plate. So that as we release this bolt, spring tension comes underneath. Now this bolt is important because there's an O-ring on the head of that bolt. That's very important for the sealing of this. So there's our bolt. Here's our upper diaphragm plate. our diaphragm, our lower diaphragm plate, our relief valve spring, our guide, and our stem assembly with the O-ring in the center, relief valve disc, disc retainer, washer, and that. So that's the entire stem assembly. Just like on the smaller series, actually just like all of the Conbraco series, going all the way back to the 40 series, they utilize this O-ring stem design, where the O-ring mounted in the center of a stem slides across a stationary spacer. The spacer, as you can see right here, the O-ring, is sealed inside the body. So this spacer mounted in there, where the stem moves back and forth like this. So anyway, that's just kind of the quick looking at the parts. Let's go ahead and put it back together. Reassembling is going to be just the reverse. Going to mount our guide with our spacer. Our relief valve diaphragm is directional. You'll notice that the diaphragm on one side has a rolled piece, like an O-ring. The other side is flat. If you'll notice on the body, we have a recess right here that corresponds with the recess on the O-ring. What they have done is they have put an O-ring mounted into the middle of that relief valve diaphragm. In other words, the cover is flat here, but the recess for that sits like this. So this diaphragm is directional. It must go where the roll is back towards the body. If we do that the other way, we're going to have a problem. So to reassemble, we're going to put it this, so that the roll goes into the body, diaphragm plates. Now we're going to catch that. This. We want to make sure we have our assembly bolt tight. Relief valve disc, disc retainer, disc retainer bolt. Again, make sure we have that properly tightened up. Now, relief valve seat, which stays in there for the average repair. Make sure the roll on that diaphragm goes to the roll in the body. When you go to insert the stem, it's obviously a blind assembly because we can't look as we're pushing this in. But what you can't want to do is, once you have the stem in place, is you want to stroke the stem once or twice. In other words, a relief valve is a spring-biased open component, meaning with no water on it, the spring is holding that open. So what we want to do is stroke that spring a couple times to make sure that we don't hear any grinding or any kind of action as we move it back and forth. That also sets the O-ring inside that body so it's working, so it's in its right location. Now, here's our relief valve cover, which goes on next. Allows us to get our clamp around it, like this. Now we're going to mount our clamp from the top here like this, catching our bolt head just like that. Once we have it in place, now we get our half-inch deep socket, tighten the clamp. Again, the cover is sealed by the O-ring on the diaphragm. It's not by the torque on that clamp. It just has to be tightened enough. You don't want to over-tighten that clamp because it does place excessive forces on that cover, which can warp things. So this is our 4A-200 series. This is the end pattern configuration where we have the ability to rotate that second check 180 degrees if we want it to go straight up. Relief valve mounted underneath. The horizontal version, like this, sitting back here so that we can see what the horizontal one looks like. The relief valve would normally be mounted on the bottom. 4A-200 series, 2.5 through 8 stainless steel body, like you see here. 8 through 10 and 12 inch will be a ductile iron body fused epoxy coated. The next model in the Conbraco 4A series is the 500 series, which is their pressure vacuum breaker. You may utilize the 4A-500 designation, or it may be the PVB-4A designation. Again, both are interchangeable, both of the models used by Conbraco. They also use the Apollo as a model name for this particular model also. So it might be Conbraco Apollo, might be 4A-500, or might be PVB-4A series. They also have a lead-free version in sizes 3/4 and 1 inch. The other sizes of the leaded bronze go from 1/2 inch to 2 inch. Ball valves, inlet and outlet, test cocks are mounted on the ball valve, not on the body, which if you have to replace shutoffs sometime in the future, you have to make sure you have a tapped ball valve for that location, because that's where your test cocks will be located. The check assembly is modular. This is what the check module looks like inside the body. Here's a set comes apart. There's our seat. I'm going to start at the top. There's our spring retainer, our spring, our disc holder, our disc retainer washer, our disc retainer bolt, and our check seat. This check mechanism is the same check that's used in the small 4A and 4A 100 and 200 series double checks NRP. Obviously, the spring load is different from the NRP version, but the same load as it appears in the double checks is used in the pressure vacuum breaker, so it makes the parts interchangeable. The air inlet portion sits on the top, and in the poppet assembly right here, there is a small little relief valve mounted in there for freeze protection. So if the assembly is installed in an area where freezing happens and it doesn't get to be winterized properly, or in time I should say, there is a relief valve which may open up and alleviate any excessive pressures in a freeze environment. So this is the 4A 500 PVB series. Let's take a look and see what it looks like inside. This is a 1-inch version of the 4A 500 series. Again, comes 1/2 through 2 inch in sizes with leaded bronze body, available in 3/4 and 1 inch in a lead-free bronze body. Inlet ball valve, outlet ball valve. On each of the ball valves are the locations of where the test cocks for the assembly are located. Notice there are no test cocks on the body itself, only on the ball valve. So if you do have to replace the shutoffs, you have to make sure you have a ball valve for the location of the test cocks. If you put a standard ball valve on there, there's no way to test the assembly. Canopy has 2 screws on the top. Loosening those 2 screws allows you to rotate the cover so it comes off. This little comes off like this so that you can leave the screws on the top and just comes off from the top. Once that has happened, now we want to remove our bonnet assembly. It threads on is sealed by an O-ring. You want to be very careful when you go to remove this bonnet assembly, because it is plastic, and if all you do is take a brute force and try to move it like this, you do have a chance of cracking it. So you want to be very gently and just kind of give it a small tapping action until you feel it loose. And once you feel your O-ring loose, it'll pop off very easily. Bonnet assembly comes off here. Bonnet is sealed by an O-ring. Underneath our bonnet is a poppet assembly with our poppet disc. We also see underneath here is a small spacer. The spacer holds that poppet assembly, not like this, inside the body. So removing the poppet, spacer, check assembly comes underneath. And just like with our 4A and 100 and 200 series, the check is modular. It looks like this. It's the same check that's used in the double checks and the second check of an RP. So when you're looking inside there, you see that spring retainer. I'll show the larger one because it's a little easier to see. By rotating that spring retainer 90 degrees, spring comes out, disc holder comes out in one piece. The seat can stay in the body for the average repair. It's sealed by an O-ring on the back side. You don't have to necessarily pull that check assembly out unless you're replacing that seat. One screw holds the disc into the disc holder. Spring, make sure it's mounted in the center of the disc holder. There's a small lip that it sits in. You want to make sure it's not off to the side. You want it right in the very center. The key thing with this check mechanism is when you go to put this retainer back together is that it rotates 90 degrees like this. You want to make sure that it clicks. There'll be a clicking sound when you get the check assembly in correctly. If you listen, there. Notice how that it pops up almost a 1/4 inch at that point, because there's where it looks like it's in, but if it's not turned, just that little extra where that engages that lip and pops up about a 1/4 inch like that, that check assembly is not going to work properly. It's going to restrict flow through there. So whether you take the check assembly and leave the check seat in the body, which is advisable, or you take the whole check assembly and work outside, that's also an option. Reassembly is going to be the reverse. Once I have the check in, the spacer just goes on top. My poppet assembly, my air inlet disc sits on here. When you buy the poppet assembly, it already comes assembled. My O-ring has to be properly lubricated. Lubrication meaning I put it on my fingers, wipe it 360 degrees around, go ahead and put it on my bonnet. Now I can go ahead and attach my bonnet on the top, engage the threads. Once I have it tightened, because it's an O-ring seal, it does not require to be over torqued. Just literally like that. That's all the tension it takes, is just that small little snapping action to make sure the O-ring is properly loaded. The cover, you line up the 2 screws from the top, like that, rotate it, go ahead and tighten your screws down. And that's our 4A 500 series pressure vacuum breaker, available in sizes 1/2 through 2 in a leaded bronze and available 3/4 and 1 inch in a lead-free bronze.